Hi, everyone, and welcome to our third PyTorch Lightning Community Talk Series. I'm joined here by my co-host, Aish.
Hey, hi everyone. My name is Aishwarya Srinivasan, or people call me Ash. Today I'm super excited to introduce to you guys Manuel, or we call him Manu, and he's joining us from France. He is a researcher and a PhD student in RIA. He has a master's in cognitive sciences and a bachelor's in physics. Manu, would you like to talk more about what you've been working on and what are the things which you are looking forward to in your research?
Yes, thanks Aish and Ari for having me here. So I'm Manu, PhD in India. She said I work on speech processing, mainly speech separation, speech enhancement based on deep learning. My PhD subject is on phase modeling for speech generative models, and today I'm working towards startup mainly based on Asteroid for after my PhD.
That's amazing. So I did look up Asteroid, and I really wanted to talk to you about this because, as a data scientist, I have worked on a lot of different use cases. But image or what audio is something which is really out of my areas of experience. So it really fascinates me how people have been building these amazing technologies around speech and around like the signal processing which they have been doing. So I wanted to talk to you about Asteroid and like what are the features in Asteroid and what was your motivation behind building it?
So I'll start with the features and talk a bit about the motivation. The Asteroid's goal is to enable researchers and practitioners in speech enhancement and speech separation to build their own models. So we provide data processing pipelines and data loaders and building blocks for their own models and example pipelines for data preparation, training, and evaluation. We also host our pre-trained models on the Hugging Face Model Hub, and we have command line interfaces for enhancement and separation if you just want to use those models. Coming back to the motivation, Asteroid was not like a big project at the beginning. It started as refactoring some messy research codes, and as I spent more time refactoring the code to publish it with the paper, well, I spend more and more time refactoring it. And I got hooked into code design, adding new features, writing the docs, having coverage, new badges, and things like this, like all these uh, open source project stuff, which gets quite addictive. And then we got our first users and contributors, and I couldn't go back. It started as a 1 week plan, and now it's really like it's a baby. And so yeah, that's about it today. The motivation is mainly to keep helping the people who are using it to uh, stay on track with state of the art and support research. Yeah, that's about it.
So I have to say, for me personally, it's a really cool package. Like for me, it's one of the packages that's definitely inspired me to learn more about audio processing. And I'm curious, you were mentioning earlier that you guys were one of the earlier adopters of PyTorch Lightning. What encouraged you or what inspired you to get started with PyTorch Lightning?
Yeah, so the original code of Asteroid, the very first skeleton was adapted from Kaitoksu repo, which was open source. Actually, we made him add the MIT license to it, and his trainer was really cool. But we worked too much time on it to improve it. And Hervé Brodin, the creator and maintainer of Pioneer Audio, advises not to do the same thing like him and actually use an existing tool for the trainer because it's a lot of time that's going to lose. And so we looked at our options and we chose Lightning. It was cool, but it was pretty early. it was actually before the 0.4 release, and variable names were changed all the time. We had to keep up with releases, which were actually coming quite fast. But in the end, the project really worked, and we benefited a lot from it and gained maintenance time and dev time altogether. Yeah, it was a good choice.
Yeah, it's definitely, I mean, it's amazing to see how far things have come since then, and how much things have stabilized after 1.0 and now 1.2 just this past week. So it's really exciting, and I'm really excited for what's coming soon. So speaking about stuff that's coming soon, like what are the types of best practices, or if somebody was getting started with PyTorch Lightning now from the experience that you've had over the past year and a half, that you would, what are the pieces of advice that you would give them?
The first advice I'd give is to use it. I think that when we use Lightning and there is a common code and common design for deep learning pipeline for training, everything gets clear. In the past, before Lightning, it was Keras, and things were clear because everyone used the same code. And now with Lightning, okay, it's more powerful and flexible, but the fact to use the same code makes things clearer. To make a comparison, we use code formatters for formatting the code, like with Black or YAP, and we do that so we don't have the mental burden of thinking about code style while we review it or write it. And with PyTorch Lightning, it's a bit of the same, but for machine learning code. When you use it, the intent just gets out. So yeah, that'd be the first advice. And once they use it, then I advise to use hooks, which are powerful mechanisms which are used a lot in PyTorch Lightning. And I think people learn to use hooks through PyTorch Lightning, and they make the code more flexible, modular, and more readable as well. So it's a cool mechanism to use.
Absolutely. I love the hooks, and I love the ability that you can like just override what you need to override. But when you don't need to override something, you have this default behavior that just works for you. So I'm with you 100%. And with all that experience and all that time working with Lightning and integrating into Asteroid, what are the dream features that you wish you had?
So this is a very cool question. I think we've been thinking about this with Samuel Cornell and Jonas Hag for a while, and what we'd love in Lightning and for Asteroid, mainly for Asteroid, probably through Lightning, is to have a compositional command line interface that can be built from the classes directly. So you take the classes signatures from your data model, your losses, your whatever callbacks you want, and your trainer, and you can compose them and create like combinatorially explosive experiments to try all your models on a given data set which was just released, or try your new model on all the data sets that existed in the past. And that's just so powerful, and I feel like we are missing this in the deep learning open source community right now.
So I love that, and it's definitely something that I'll be advocating for with the rest of the team. My understanding is you were saying that there's also an open pull request for a sample implementation open, right?
Yes, it's. I'm not sure what's your decision internally about that. It's based on, I think, JSON argparse, and it has really cool features, but it raises a lot of questions which weren't addressed. So but it's a cool PR for sure. Absolutely.
Well, I look forward to discussing it with the team more. And I want to thank you again for taking the time. I know it's late in France, so thank you. It's definitely late here in Tel Aviv. So thank you again for coming out and joining us. For those of you who are watching at home, feel free to check out Asteroid and take a look at the project, especially if you're doing audio processing. Really cool, state-of-the-art models, just accessible at your fingertips. And with the Lightning integration, it makes it very clean to iterate on top of that. And again, thank you for joining. follow us on Twitter and like and subscribe below. And if you have additional questions, feel free to reach out to us in the comments. Thank you.
Thanks.
Thank you.
Bye.